Okay, let's dive into this. We're going to talk about one of the true unsung heroes in the world of electronics, the Zener diode. It's this tiny component that, believe me, plays a huge role in keeping all our favorite gadgets from, well, blowing up.
I mean, have you ever really thought about that? You plug your $1,000 laptop into the wall, and you just assume it's going to be fine. But the power coming out of that socket, it's messy, it's noisy. So what's the magic trick that stops a random power spike from turning your circuits into toast?
Well, here's the deal. The little chips and processors inside your computer, they're really picky. They're like divas. They need a perfectly smooth, rock-steady voltage to do their job. Any little hiccup, a spike, a dip, what we call noise, and they can start acting weird or just get fried completely.
And that gets us to the heart of the matter, the unstable voltage problem. See, when we convert the AC power from our walls into the DC power that electronics use, it's not a clean, straight line of power. It's got this little wobble, this wave, that we call a ripple. And for sensitive electronics, that ripple is a total deal breaker.
And cue the hero music. This is where the Zener diode steps in. This isn't your average run-of-the-mill diode, no. This thing is a specialist. It was born and bred for one purpose, to take that unstable, wobbly voltage and tame it. It's basically a bodyguard for your circuits.
So, what's so special about it? Okay, think of a normal diode like a one-way street for electricity. If you try to ram current backwards through it with too much force, you hit what's called the breakdown region, and bam, catastrophic failure. The diode is toast. But a Zener diode lives in the breakdown region. It sets up a lawn chair there. What means death for a normal diode is just another Tuesday for a Zener. That's its whole job.
So yeah, this whole breakdown region thing, that's its superpower. It's how the Zener works its magic. Let's dig in and see how it actually pulls this off.
All right, so every Zener has a magic number printed on it, called its Zener voltage, or VZ for short. The second the reverse voltage hits that exact number, the Zener intentionally breaks down and locks the voltage right there. It acts like a bouncer at a club, putting its arm out and saying, nope, the voltage goes no higher than this. End of story.
And this number isn't an accident. It's cooked right into the silicon during manufacturing through a process called doping, where they add specific impurities. This means engineers can literally order up a Zener for pretty much any voltage they need. You need to lock a voltage at 5.1 volts? There's a Zener of that. 12 volts? Yep. It's incredibly versatile.
So now we know what its superpower is. Let's see how we put that superpower to work in its most common job, being a voltage regulator. This is where the rubber really meets the road.
You know, the best way to picture this is to think of a pressure relief valve, like on a boiler. Let's say your circuit needs exactly 5 volts to be happy, but your power supply is giving you 9 volts. The Zener acts like that relief valve, bleeding off the extra voltage so your sensitive circuit only ever feels that perfect, steady 5 volts. It just shunts the excess away.
So, in a real circuit, here's the play-by-play. The power supply pushes out all the current. The main component, we call it the load, takes as much current as it needs to work. Then, our clever Zener diode, which is sitting on the sidelines, grabs all the leftover current and safely sends it to ground. By doing that, it keeps the voltage across the load perfectly constant.
But of course, there's a catch. It's not magic. The Zener can't handle an infinite amount of current, and it can't work with zero current either. The whole circuit has to be designed to keep the Zener in what we call the Goldilocks zone. The current has to be just right.
And there are two really critical limits here. On one end, if the current through the Zener drops too low, below a point called IZK, it just turns off. It stops regulating. On the other end, if you push too much current through it, past its maximum ISM rating, it gets overwhelmed, it overheats, and it gets destroyed.
Okay, theory's great, but let's make this real. Imagine we've got a 10-volt power source, and we want to use a 5-volt Zener to protect our component. Turns out the resistance of that component, the load, is everything when it comes to keeping our Zener in its happy place.
So for this specific circuit, let's say the absolute maximum resistance our load can have is 250 ohms. Now, why would there be a maximum? That sounds kind of backward, right?
Well, think about it. A higher resistance means the load is less thirsty for current. It doesn't draw very much. So if the load isn't taking its fair share of the current, where does all that leftover current have to go? You guessed it, right through the Zener. And if that load resistance gets too high, it forces a flood of current through the Zener, pushing it past its limit and burning it out.
Okay, so what about the other direction? For our little circuit, the minimum load resistance is 100 ohms. What's the danger if we drop below that?
A lower resistance means the load gets greedy. It starts pulling way more current. If the resistance drops too low, the load hogs so much current from the power supply that there's not enough left over to keep the Zener diode on in its breakdown mode. The Zener is basically starved of current, it switches off, and poof, your voltage regulation is gone.
Okay, we've covered a lot of ground, so let's just boil it all down. What are the big ideas you absolutely need to remember about this awesome little component? Here are the essentials. First, Zener diodes are basically voltage bodyguards. They exist to create a stable, constant voltage. Second, their superpower is that they are designed to work in the reverse breakdown region, the very place that kills a normal diode. And third, to use them, you have to be a bit of an artist. The entire circuit has to be balanced to keep that Zener in its Goldilocks zone, not too much current and not too little.
So that leaves us with one last thing to think about. We've talked about computers, sure, but just look around you. Your phone charger, the smart speaker on your counter, your TV. How many of the gadgets you rely on every single day have one of these simple, clever little components inside, quietly protecting their tiny electronic brains? Something to think about, right?